What's up everyone, this is LeetCode 57, insert interval. We've done this problem in Python, now we're doing it in C++. So basically we're given a list of intervals, right? And we're given a new interval, and basically we need to insert new interval into intervals, right? Now if there's some overlap somewhere between a given interval in here and new interval, we need to do a merge. Otherwise, if there is no overlap, we just add it in the appropriate place. And intervals is sorted for us according to the starting point, right? So yeah. Now if you've never done this problem, it is a little bit hard to wrap your head around, at least in my opinion, just because there's so many edge cases. So I like to draw it out, right? A little bit easier. Right? Here's example 1. This is basically what we're doing. We have a list of intervals, right? And we have a new interval. As you can see, there's some overlap right here, right? So the way we basically do the merging is we basically take the minimum between the starting points of the current interval and the new interval. We take the minimum, and then for the ending points, we take the maximum, right? So it'd be 5. So that's how we get 1, 5, and this is what our merged interval looks like. And again here, there's no overlap or anything, right? So we want to put it in the appropriate place, and this is basically what our output looks like. Okay. Example 2, a little bit like this, right? No overlap here, so just put this in our array. And by the way, you can do this in place, but it is not required for this problem. So I'm not going to do it that way, but I don't know. I mean, I guess it's good to practice. Some interviews might ask you. I don't know why, but I don't know. I guess it depends on how hard your interview wants to make your day, but you don't need to do this in place. This was not here before, but they did specify now that they actually don't care if you do it in place or not. But anyways, we're not doing it in place. We're just creating a new array and returning that. Okay, so no overlap here. So add this to our array. Now compare this to this. We see there's overlap. Now programmatically, how do we know there's overlap? Right? How do we check at each interval? How do we check if there's overlap? We basically check the ending interval for the current, or the ending point for the current interval we're on. Is that less than the starting interval for the new interval? In this case, it is, right? It's less than that. So we know that there's no overlap. Here though, we see that this point here is not less than this point here. So we know there's overlap, right? So we need to mix this 3 and this 5, or we need to take the minimum, right? So we would get a 3. Take 5 and 8. What is the maximum? It'd be 8, right? So 3. Oh, this is wrong, by the way. In my other video, I had this wrong. I didn't correct this. This is actually 10. My bad. But initially we do 3 and 4, right? Our minimum is 3, 5 and 8. Our maximum is 8, right? But we go here and we see that we have some overlap again, right? This is not less than this. This is not less than this, nor is this point here greater than this point. So we know that this point isn't to the right, nor is it to the left. There is some overlap. So we have to check it again, okay? 6 and 3, 3 is the minimum, okay? And we check 7 and 8, right? 8's the maximum. So basically this stays the same, okay? Which makes sense because this is completely overlapping with this. So this interval here would be actually the merge interval would basically just remain the same. Okay, we move on to this next point. This point here is not to the right of this point here, right? Because they're actually directly overlapping, 8 and 8, right? So again, we check this 3 with this 8. 3 is the minimum, keep that the same. Now we check this 8 with this 10, and 10 is actually greater, right? So this is 3 and 10, okay? That's a typo here. And then here, right, we check this. This point here is greater than this point here, so there's no overlap. So basically just add everything from here onwards, right? Well, before we add everything from here onwards, we want to add this to our array, okay? This merge interval, because we're not actually adding it to our array right away, because we don't know if any point later on, like after, you see how there's more overlaps as we go along? That's why after we handle this interval, we didn't take this merge interval and put it on our array, right? We don't want to do that because we could have other points in the future that overlap. So we don't want to actually prematurely append anything to our output. Okay. Let me think of some other edge cases, right? We could have something like this, right? Then something like this. We can only have one interval and a new interval and they overlap, right? So at the end of our program, we actually want to append this. The reason I talk in this way, like we want to append it and do this, it's because we want to append it depending on the circumstance, okay? And we'll see that in the code. So first of all, actually I'll just do it in the same line. We'll say so intervals. This is a list of a list, right? We have these lists, and they're in a list. So the actual list itself, meaning this all can be empty, right? Because at minimum it can be 0. So the intervals doesn't have to have anything in it. However, these points here will always have a length of 2, right? Because we have a starting point and end point, right? And as you can see here, interval.length, well, this is a list, not a list of a list, right? That's why this is 2, but this is 2 also. Because this is what these 2 points here are telling you, this constraints, is that if there is something that exists in here, it will have a starting point and end point, so it'll always be 2. However, the actual length of this intervals can be 0, meaning we could have an empty list essentially. Okay. Here though, it says new interval.length is equal to 2, meaning we'll always have a starting and an end point. So what is that telling you? That's telling you new interval will always exist, but intervals technically wouldn't exist. It can't. There is a possibility it doesn't exist. The variable exists, but it could be empty, right? That's why less than or equal to 0. It's possible this is the length. The intervals.length, right? At minimum could be 0, not less than or equal to 0. I don't know why I said that. Greater than or equal to 0, right? So intervals.length could be, we could have basically one coordinate point. I don't know if coordinate point's the right word, but we could have one set of numbers or 2 or 0, right? So you could have something like this, right? And we would have to do this. But you also could have something where, right, let's say this doesn't exist. Intervals doesn't exist. In that case, you just want to take new interval and return that, okay? And so that's the edge case we're handling here, okay? Okay, moving down. So when we're at an interval I, right, the starting point would be 0, the ending point for that specific interval would be 1. I'm just going to use variables so I can do this, right? Intervals I start, or interval, the given interval's endpoint, right? So I can just reference it like that. If I use a bunch of numbers like 0 and 1, it might be a little bit confusing, okay? So that's why I'm doing it like this. Now let's make a vector for our result. Okay. Now let's iterate. 4 into 0. Okay. Now let's say we have a case where the new interval is to the right of the current interval. Right, that would be a case where the new interval is to the right of the current interval. So let's say we're iterating through this. When we're at this point here, we see that this is to the right of this. How do we check that? How do we know that this here is to the right of this programmatically? Well, we look at this endpoint, and if that is less than the starting point for the new interval, we know that this is to the left, okay? So we're going to say if intervals of I of end is less than new interval start, then we push that to the back. Okay, because if this is to the left of this, we just add this to our output array, right? Because there's no overlap anywhere, okay? Because it's to the left, okay? Pretty simple. Handle another edge case. Now, if we have something where this is to the right of this, right? The current interval is to the right of the new interval, right? Or another way to say is the new interval is to the left of the current interval we're on. We basically want to take this interval right here, and we know nothing after this point is overlapping, so we can just take this, append it to our output array, and basically from here onwards, take everything from here onwards and put that in also into our array, because nothing from here onwards will overlap, right? So if we have a bunch of points here, basically we want to append this merge list here to our output array and basically take all these points and append that afterwards, okay? That makes sense? Hope it makes sense, right? Because we don't want to append after we check this here, right? And we merge these points. After we do a merge here, we don't want to append that to our output array because maybe some point in the future over some interval in the future overlaps, like right here or wherever, right? However, when we finally reach an interval that is to the right of new interval, that means this merged interval is fully merged. Okay, there's no other points that overlap. So we'll take this, append that to our output, and every point from here onwards, we append that to our output as well. Okay, because none of them will overlap. So we would basically say if intervals of I of start is greater than new interval end. Oh, I already have some brackets. Whoops. Then we'll push the merged interval, which would just be new interval. The way we're doing this merging is we're just updating new intervals, starting and endpoints. Okay, that's how we're not gonna make separate variables or anything. And then from here onwards, we basically want to insert what we're doing here is give at the current index from there onwards append everything to the resulting array. Okay. Then we return res. Okay. Now one final point we have to handle is here, which would be where there's an overlap. Okay. So I don't know. When we're doing this, how do we handle this? Again, remember, we take the minimum of these 2 points, of this point and this point, the maximum of this point and this point, and we create our new interval looks like this. This is not appended to our array quite yet because this could be extended, right? If we have another point here that overlaps. So even though this is white here, technically after we set the new and end points for the new interval, after we update those, we're not actually adding it to our array quite yet, our resulting array. We're going to say new interval. New interval. Okay. So basically take the minimum of the starting points and the maximum of the ending points, and that's our new our quote unquote new merged interval. So technically what we're doing is, I mean, in theory, what we're doing is this is our new interval. In theory, what we're actually doing is just this, right? We're basically making it bigger so that we merge this into this when it's overlapped, okay? And then if we get to a point where we hit another interval to the right, we basically append this to our output. Now, we could have a case also where this doesn't exist, in which case at the end of our program, we add this to our resulting array, okay? So that's how we handle cases where maybe this doesn't exist, okay? And that's the point where we would handle that is right here, okay? Right, because let's say we have an edge case like this, right? And we have, I don't know, some interval. Well, technically what we would do is we'd compare these minimum points and our new interval would look like this. And this would stay the same, the maximum or the endpoint. There's nothing else though, so after we finish going through all the intervals, we still have this to put in our final array, right? And that's what we're doing down here. Whereas if we have an interval that does exist though, to the right of that, then that doesn't matter because this gets added to the output anyways because we do that right here, okay? So we'll handle both cases where this exists or doesn't exist to the right of the current, to the right of the new interval, okay? So yeah, like I said, this problem is, I'll just say this, edge cases. It's not that this problem is hard necessarily, it's just that you have to think and consider of all the edge cases, and that's what makes this problem tricky. Just wrapping your head around that. Like the code isn't that hard, I don't think. It's just like logically thinking and picturing stuff, and drawing the stuff out really does help. So, I mean, if there's an edge case you can think of that you're confused on how it works, like I recommend just doing this and drawing it out. Okay. Anyways, I hope this helped, and I'll see you in the next one, but let me submit first. Oh, I see what I did, my bad. Whoops, that is a mistake. I needed to do that as well. I accidentally put everything outside of my class, my bad. There you go.